Set up a simulation study. In this video, we'll set up a linear static stress simulation study, we'll solve a simulation study, and we'll review the results. In Fusion 360, we want to carry on with our exported generative swing arm outcome, or you can upload the supplied dataset gen swingarm.f3d. Once we create a 3D design from a generative outcome, we can navigate to the simulation workspace. And once in the simulation workspace, we're asked to use the information set up by the generative design for our new static stress study. We can simply say yes, and then all of our loads and constraints and information is brought directly into this simulation study. This includes the materials that we chose for our final outcome, in this case aluminum, and all the various load cases. In this case, load case 1 should have been our full compression. So if we take a look at these loads, you can see that we have a full compression load, and then we have the bearing load on the shock. Everything else looks like it's fine in terms of the setup. So from here, we can check the pre-check to make sure that we have all the required information, and then we can simply solve the study. Unlike a generative design, you can solve a linear static stress study locally using your PC's resources or on the cloud for 5 cloud credits. If you need more information about cloud credits, make sure that you select Learn More, and remember that you can modify your view options to show cloud credit costs and balances. I'm going to go ahead and solve this, then we'll check back in once we have our results. Now that we have our results, let's go ahead and take a look. One thing we'll note is that the factor of safety currently is 0.28. This is well below the factor of safety in our objectives and limits. One thing that we need to understand about the difference between our exported design and the simulation results in generative design are the fact that all of our preserves were converted to mesh bodies and included in the overall study. So for the final design, the mesh bodies and the T-spline body that was created are then combined, which means that we have sharper intersections than we did in the original mesh. So we can see this, in this case, we have these high areas of stress concentration. This is okay because for this design, ideally we would need to reconnect this to the top, which means that we would need to do a lot of adjustments in this area. This is only for a single load case, and the wheelie load case is where we have the maximum load pushing forward. Let's go ahead and take a look at load case 1. The factor of safety is a little bit higher, and this was the max compression. You'll notice that it's 0.298. If we go to torsion, you can see that it's on one side a little bit higher than the other. Torsion 2 should reverse and we see more on this side. And then we have our bank left and bank right. As we look at all these different safety factors, you'll note that they're coming in these sharp corners. And again, it's all located right here in the center where we have our shock mount. Everywhere else seems to be okay in terms of stress concentrations, but let's move on to actually take a look at the stress results. We can see again the maximum stress concentration is right here around the shock mount. We go back to the maximum load case and we move our way through the torsion and banking. We can see here again, this is really where it's located. So for a design like this, ideally what I would do is I would remove a lot of these supports that have been created and reconnect them to the top of this block and also incorporate them into the top sections of this design. It doesn't mean that the results from the generative study are incorrect. Again, it really comes down to the fact that the results in the generative study are using an entirely converted mesh body, where in the final design, we have the intersection between our form body and the preserves that were created. So keeping this in mind, again, it's important to note that we should go back to the design workspace and spend some time modifying the form body. This can be done by editing the form body and taking a look at ways in which we can reconnect this geometry to the top. This is a big process and takes a good bit of time, so it'll be included as part of the course challenge. But in this example, we're not going to be doing any modification to the design. We're simply identifying it and validating it through our simulation results. Everything else in the swing arm looks pretty good. I'm happy with the shape. There are some areas where I would want to make some adjustments. For example, not having this combine feature and then going back through and hiding all of these obstacles. Let's go ahead and simply show hide. You can see that the inside no longer has that small cutaway. So these are things that we would likely adjust because we have plenty of clearance with the tire. We can see this by saving the design and going back to the original assembly to make sure that we do have that clearance. For now, however, if you make any adjustments or changes, make sure that you do save this design before moving on.